So I'm Rohit. This is about basic shell commands and how to write shell scripts. So what is the shell? In the most general definition is it's the interface to your computer, and a shell can be a graphical shell. So Windows has a graphical shell. If you use Ubuntu, this whole thing, this is the Unity interface. It's called the Unity shell. And what you see in movies, what the hackers use, and what's inside this terminal where you type in those commands, it's called the console. And this is what we mean by the shell today. So we'll be learning a few shell commands that you type in by hand, and we'll also write a few scripts. Scripts let you combine different shell commands and automate certain things. So we'll see how we can do all that. So why do we need to learn to use the shell if we already have a graphical interface with the mouse and icons and everything? Why do we still need a shell? So what if an asteroid destroys all the graphical user interfaces? Then you'd have no other option. You'll have to somehow figure out how to use it. But till that happens, here are a few good reasons. When you are doing server maintenance, so web servers are stored in server farms, hundreds of those machines in a single rack. They don't have individual displays and keyboards, and so you're supposed to connect to them remotely and do your administration remotely, and you do that over SSH, and all SSH gives you is a command line like that. So you have to know how to administer your system, install updates, install applications through the shell. The other thing is running the whole graphical system. So this whole thing, you see the transparency, the blurring, it's all visual effects, and this requires CPU power, GPU power. I mean, you cannot run Ubuntu unless you have a graphics card driver installed. If your drivers are missing, you'll get all sorts of errors, and this whole thing, it won't even run. So it's taking up resources, right? So if you have a resource limited machine, or if you're running a server and you're trying to conserve resources on the server, you're not going to have a graphical interface. You're going to have to use a terminal. And shell commands can do just about everything you can do from the graphical interface and even more. And on Ubuntu, the terminal program, the shell can be accessed to the program called terminal. So you can just go to the start menu and type in terminal, and this icon is going to show up, or you're going to see it here on the side. So this is where this is your Linux shell, and you can run commands here. So if you're a Mac user, it also has a built-in terminal application. So Mac users also have this option of doing stuff on the command line, and it's found under this menu. If you're using Windows, so first of all, we recommend that you run Ubuntu on a VM virtual machine and try everything on that. But otherwise, you can SSH to the Omega or Gamma servers, which is another thing we've discussed before, and you can try these commands on those. I wouldn't suggest trying the commands which can delete files and things like that. Don't try those try those commands on your own machine, because bad things can happen. And on Windows, there is another thing called the PowerShell. It started shipping with Windows 8 or something, and it's similar to the Linux shell, but it's not the same at all, but it's there. There's another program called Cygwin, and then there is another program called MSys, Minimalistic System for Windows. So all of them give you a shell that has some of the Unix commands that you can run. So the next couple of slides, you may have already seen them if you've attended our previous meetings, but I'm just going to go over these really quickly, okay? So I have these handouts here up front. If you don't have them, please, does anybody need these? This will be a little easier to follow along if you have this on here. So few very basic commands are pwd. I mean this. How many of you have no idea what these commands are? Like who are just seeing these commands for the first time, and it's okay. Right. So, but you do use Windows, right? And on Windows you have folders. You have your home folder, right? I mean, you don't have a home folder, but you know what folders are and directories are. So I have a Dropbox folder, and within Dropbox I have this lug folder. Within the lug folder I have a folder for today's presentation. So in the console also you have a position where you are. So if I run the pwd command, it tells me I'm in my home directory, Dropbox, lug, this folder. So that's because sometimes you see it here, but sometimes you don't. It depends on the system configuration. So you might want to run this command just to be sure. A few other commands are ls to list all the files. So these are all the files that are in this folder, and then the cp command will copy a file, and the move command will rename it or move it to a different location. The rm command will delete a file, and we've said this before that there is no recycle bin when you use the rm command. So if you delete something, you won't be able to recover it. It will be very difficult. So if you're not sure, then don't delete files through the shell unless you're absolutely sure what you're deleting. Then the cd command can be used to switch between directories. So I'm in this folder. If I want to go, so dot. Okay, cd dot means stay where you are. Dot means the current folder. If I do cd dot, it means take me one folder level up. So it's going to take me to lug, right? If I want to go back to this folder, I'll say cd, type in the name, and it takes me back. So this is like your navigation tool to move between folders and things like that. And then mkdir, you can make folders through the shell. Let's make something, mkdir. So if I go back, so this is the new folder that I created. So again, we are not here for these basic things. These are, you would probably want to do it here, right? We are here for the other stuff, but again, a few more commands, then we'll get to scripting. So a few commands that work with files. The cat command, it stands for concatenate. It basically it takes a file and it prints it on the console. So if I say cat print this file, it's going to print it on the console. Now, it's by itself, it's not very useful. It's mostly used to pipe the output into another command. So if you have another command which is expecting some input from the keyboard, from the input, so you can use the cat command to feed some other file into that other program. So that's its primary use. Other than that, people don't use the cat command. Then there is the nano editor. We won't look at that. It's fairly easy to use. Then there is the grep command. We're gonna discuss about that in a better way. But the basic syntax is grep and then a pattern. For example, this file I want to search for my name, right? So if I say grep Rohit and then the name of the file, it's gonna go through the file and it's only going to print the lines where it finds the pattern. So my name is on this line and this line, these two lines. So these are the only two lines that get printed. Yeah.
So before we go any further, what command is the best one to use to list all commands that you can use in the shell?
Oh, all the commands that you can use. I think the best thing is to search on the internet.
No, there is a command, some sort of com gen com, weird name over that.
I'm not sure.
But it will include more than just shell command.
Because most commands are, so there are a few commands that are built into the shell.
Most programs you can have a command that will tell you all the possible ways you can use it, so I think there should be something.
Okay, yeah. So this is one command that I remember. If you know something about something, like I want to copy files or something, so you'll do apropos copy. So it's going to search through all the manual pages of all the installed programs, and whichever program matches this keyword is going to list all of them. Like there is no built-in tutorial that comes with the shell, right? So it's only commands and their own manuals. So every command will have its own help page.
Yeah.
Or you can go on the internet and search for the most useful shell commands, and you will get a list or something. So the handout that I have today, it's some of these commands are most of the ones that you'll use. Yeah. But if you're trying to do something, for example, let's say I want to do file transfer. So if I run apropos, apropos with some term, and it's going to print out all the commands which have that search keyword in their help manual. So some of them might be irrelevant. For example, memcopy, it's probably not related, but FTP is there, so you found FTP. But yeah, this is probably a good command. You can make a note of it. Sorry, these commands here. Yeah. This should help. But otherwise, I'll just say go with the tutorial on the web. That's the best thing. If you really want to learn everything. I usually
help will give you a slightly different output than man, but
yeah. But yeah, so there is this command called man, which prints the help for a particular program. So for example, the grep command, if I say grep man grep, it will show up the manual page. Okay? So most commands are like command and options. So I didn't, in my list, I didn't write, actually I did put a few useful ones, but the basic syntax is the one, so everything in square brackets is the optional stuff, so you can always skip that. So you can say grep, pattern, and even the file is optional because you can feed the input through your keyboard, right? So that's the most basic use is grep, pattern, everything else is optional. Or you can do grep, pattern, file name, that's one combination. And then you can start adding switches, like print the line numbers, print this, print that, all those things. And you'll find these switches listed here. So I have these on the most useful ones that I use all the time are here. And another thing about man pages is if you scroll down all the way to the end, so maybe not this particular command, but most other commands, at least some of them have an example section at the end. And it'll have a few examples. The most common users of that command, they'll have a very good example with a description. So if you are trying to figure it out, just do that. And there's another command, info grep, info, which is they say it gives you a more detailed help than the man command, but I've never really noticed that. It's usually the same thing. You might
different fields, but a couple of things that it info picks up and grep up and vice versa.
Yeah.
It's very minute.
Yeah. Okay, so you have like 3 commands for help. If you ever stuck with something, you can use the apropos command or the man command or the info command. Okay. If you to do any, so on Linux, you are restricted to stay within your home directory. So my home directory is home Rohit. If I try to change any files outside of this, if I go one level up, and if I want to create a directory here, it's going to fail because I don't have permission to write outside of my own home directory. So I mean, you shouldn't be doing that anyway, right? You're just supposed to work in your own home directory. But if you are the system administrator and you are supposed to do it for somebody, or you're doing something, you have to delete a user or something, you can use the sudo command, sudo mkdir test. So it's going to ask you for your password, and it's the command is successful now because you use sudo. Sudo stands for super user do. So you run the command as root. If you see the ownership of this file, you'll see the owner of this file is the root user. It's not me. If I go to my home directory, if I do a listing, you'll see I'm the owner of all these files because I made them. But that folder that I just made, it was made acting as the root user. So this is like a cartoon. So if you tell Linux to do something, it's not going to do it. If you say sudo, it's going to do it. But yeah, just be careful. You should not be using sudo for most things, right? Everything that we did before this command, we didn't have to because we were in our home directory. Just because we are all using Ubuntu, I'm guessing a few commands that you should know of. The apt-get command, you can say sudo apt-get update, and then sudo apt-get upgrade. It'll just update all. It's like Windows Update. It'll update all the software packages. So, it's not important on your machine maybe, but if you're running a system, a web server or something, you should do this regularly so that all the security patches are applied. So for example, on your machine, so on Linux, on Ubuntu in particular, you have this program called the Software Center, right? So you can go there and you can search for applications and you can install them. Just make sure that you have install the free applications. There are a whole bunch of paid applications which I don't think are worth the money. But this is like the App Store, the Play Store. So you search for an app, you install it. For example, I just installed this screen recording app that I'm running right now. I just installed it a minute ago. I just searched for it and then I clicked on install. And now I'm using it. So it's fairly simple. You don't have to go to websites and download things. For most things you don't have to do it. But you can do most of this from the command line too. So if I wanted to install the C compilers, apt-get install, and then you type in the name of the package you're installing. So anything, like Java or any program. Okay, it's gonna search through the list of packages and it's going to try to install it. I'm not going to try these commands. So now we can just go and look at the first handout, which has this one. So very quickly, we have already discussed all these commands. I'll just talk about these extra cases that are not in my slides here. So the ls command, you all know it prints the list of files. But if you do ls-l, so let me just go to my so if I do ls-l, it's going to show me the file names, then the modification date and time, the file size in bytes, then the file owner and the file group, vice versa, and then the file permissions. Again, we'll talk about this maybe if we need to, but this has more details about the files. Yeah.
Is it the most recent modification date?
Yeah. And so another option is T, which will sort them in the order of the modification date. So the oldest file is at the bottom and the newest file is at the top, right? Sometimes you want the reverse, you want the newest file at the bottom because you don't want to scroll all the way up to see. I mean, most of the time you want the newest file, right? You don't care about the oldest one. So if you add an R, it just reverses the order, and this is the most recent change I made, right? I made this new folder. So this is helpful if you're trying to see what what you've been doing, what changes you made recently. Then the cp command, you know that you can give a file name and then a destination file name. But if you do -r, it's going to copy complete folders from one place to another. So it's recursive. Then the chmod command. So we'll actually use it in a while, but the most common use is to make your script executable. So if you look in the listing here, so these are normal files and this is a script. So you see a different color, but you should notice something here. This particular file has an X here, which means it is an executable file. You can run it. All of the other files, they do not have this. So if you try to run them, they won't run. So let me first run this file and show that it runs. Right? So it runs, gave me some output. If I try to run something else, like the file compact, so it won't run because it's not an executable file. Although it is a script, if I show you the contents of that file, it is a script. It was supposed to run, but because you didn't set the permissions, it doesn't have permission to run, it won't run. So you can do the chmod command. Chmod plus X means you're adding the execute permission and then the file name, right? So if I look at it again, you'll see this file has been given execute permissions. So I can do this now, and this script has become executable. So this is something that you do all the time when you're writing scripts, and sometimes when you're making a website and there's going to be some shared locations. So there you might want to change the permissions of some files so that others cannot read them, because you can remove read permissions and others won't be able to read those files. But let's not talk about it. Then pipes. So the ls command, the output, it's too long, right? It's scrolling off the screen. So if the less command, usually people just pipe into it. You just type the pipe character in less. So it's going to show one page of information and it's going to wait. And then you can press enter or space rather, and it will just go to the next page and so on. So it's for scrolling through large portions of text one page at a time. And you can hit Q to exit. The echo command, I mean, it's nothing, right? But its most common use is with variables. So when you're writing a script, you will want to use some variables in that script, and so because I want to do it quickly. So I'll maybe not demonstrate every single command. So if you want me to, just let me know. But I'll just try to just go through all of them. The man command, okay, the env command, it just prints all the predefined variables that come on your machine. So there is always a variable called home. That's your home directory. There is always a variable called path. There are a whole bunch of variables. Some of them, and you might use some of them in your script sometime, someday. Okay. Then the man command, and then the grep command. So here are a few options for the grep command, because searching in files it's kind of important. So if you add the -i, it makes it case insensitive. So uppercase, lowercase don't matter. -v negates. So instead of printing the lines with the pattern, it will print the lines without the pattern. H will also print the file names. N will also print the line numbers. And so remember how I ran this command earlier? If I also want to see a few lines before and after each match, I can say, so now it prints the line where the match was found, and it also prints 2 lines before it and 2 lines after it. So this is useful sometimes when you're doing something. For example, like I have this example here. So, and this is a misprint in the handout. So here you will see something different in that piece of paper. So if you want, you can make this correction. But what I'll do with this command is so this is I have a whole bunch of source code files in this directory. So I'm trying to. So I'm going to look for the word to do, because sometimes I put a little to do in my code and write some statement like to remember later. And this means only search files will have a .cpp extension. And the R means it will look for the files in all the subdirectories, all the files everywhere. And it's going to print, I think, 3 lines before and after. So here, basically you see where you wrote something and what you were trying to do over there. So that's just one example, okay? Then the find command, So I mostly use it when I have to do something in bulk on a whole bunch of files. So by itself, the find command, it just returns a list of files which match something in the file name, right? So if you do if I do find dot, it just lists all the files, and then you can add some search criteria, like in the name it should have star.sh, so all the files with .sh in the name, right? I mean, you could have done this way too, right? But the difference is that it also searches in the subdirectories. The find command, if I do it in my home directory, run the same command, it will go through each and every folder in my home directory and give me a whole, like a big list of files. So that's the difference, that's the use. And then in terms of options, you can change name to iname, which will make it case insensitive. And then this is a useful option. So let's say I want to run a command on every file, every search result, I want to do something on that. So in this example, this command by itself, it counts. So if I see wc minus l and then the name of a file, it will tell you how many lines that file had. So if I want to perform this operation on every file, I can use the find command with this option, -exec word count minus l, and then this special combination. So every time find will find a file, it will run this command and it will substitute this file name over here. So you can use it multiple times and you can create some very complex operations using the find command. So So by itself, the find command just prints file names, but with the exec option, you can actually do an operation on each file. You can use the copy command and copy the file to some other location and things like that. So that's more advanced usage. And then the set command is another important command because it is used to replace. Mostly, it is used to make substitutions. This is the most common use. You have a pattern and a replacement. This is a special case where, what set does is, let's say, set C. So let's say I want to replace my name with something, okay, and in that file. So you see my name has been replaced by cat, right? But it prints the whole file, even the lines where nothing was matched, no substitutions were made, everything gets printed. But if you use this other format of this command, because sometimes you don't need everything. You're looking for something very specific, and I mean, if you do that, it prints nothing really. It goes silent. But to actually print what matched, you need to add a P here, and it's going to only print the lines where the change was made. Okay? So -n makes it silent, and P prints only the matches. Now one use is, so let's say the ifconfig command. So usually this command, it prints your IP address. So my internet address is this. So I can use the set command to extract this whole my IP. So how can I do that? Let's use the same thing. So the same command. Now instead of running on this file, I'm going to pipe the output of ifconfig into sed. So the ifconfig command is going to run, and all of this text will become the input to the sed command. Now it will try to do something similar. What I need is this, and to identify it in all of this, I could look for this, right? This is a piece of constant text that will be there every time. It's kind of marking where the IP address is. So if I search for that, I'm just okay. Let's just see what happens with this. So it only prints the lines with the word inet address. Actually, there are two lines. This. Both of them get printed. It makes a substitution, but this is not what I want, right? I just want this here. So I'll need to match this guy here. So what is this? This is a bunch of numbers and dots, right? So we use something called a regular expression here. So there's this. So if you put any thing like 0 to 9 in square brackets, it means it'll look for and match numbers 0 to 9. So I'm hoping this is visible. Right. So what happened this time was it matched inet address, and then it matched the first character, because this is a number, right? So this whole pattern got replaced by cat. Actually, okay, here. Yeah, here. So you see the one is missing because it's part of the search text now, and it got replaced. Now I'll have more than one of those, right? So to specify more than one, you have this plus thing. So if you put a plus after any character or any search pattern, it'll count it multiple times. So now it didn't match. So for the plus, you need a backslash in front of it because it's a special character. So now you see the whole of this 10.192, the whole 10 got matched, but the dots still haven't been matched. So all you need to do now is add a dot here. Is it? Yeah. So if you compare this to what you see here, so it took all of this and it replaced this by cat, right? So I don't want to replace it with cat. I want to extract this portion, right? This portion made up of numbers and dots. So to extract something, you would put it within slash brackets, escape brackets, and then you would replace the whole thing. So let's just run this and see what happens. So something's happening, right? It's changing stuff. Let me do one last thing, and then I'll explain what's going on. Dot star and a dot star. So see, now it's doing what it's supposed to do. It's only extracting the IP. And how is this working? So let's look at the expression. The dot star means match anything. So it will match anything, it doesn't care till it sees this. So anything still means that it still has to look for this. So it will match anything that has this somewhere in it. And then it's going to, within those brackets, so slash parenthesis, within that is my, you could say it's called the match. It's called, I think it's called the group. So I've grouped all of these things together, and then I'm looking for numbers 0 to 9 or a dot in any order, it doesn't matter, and more than one occurrence. So slash plus means more than one occurrence. And then after that could be anything else, so dot star. And so it's matching the whole line from first character to the last character. And for the replacement, the second part is the replacement. The \1 is referencing the first group. So remember those brackets, they are your groups. You can have more than one. You can have one here, one here, one here. So the first one is /1, the second one is /2, and so on. So you took that whole line and you replaced it by that. So we'll be doing something like this in our script in a while. So there are other combinations like, so we will discuss this some other time.
Does the set replace the actual, change the actual file? Or
No, it doesn't. It doesn't change the file. So what's happening is ifconfig would have printed to the screen, but instead of printing to the screen, it's now going to the input of the set command, and the set command is just going to print it to the output. It doesn't change the file. There is an option, I think, that lets you change files, but usually what you would do is you would redirect it to a temporary file, into a new file, just dump everything into a temporary file and then rename it to, or copy it over the old file. So don't try to overwrite the existing file. So that's, if you're doing something like this, do not do this because set command cannot handle reading and writing from the same file. It will crash. So what you should do is you should dump it to a temporary file, and then you can rename it, delete the old one and replace it with this new one. So that's the set command. And then like what's a script? So a script will take a bunch of those commands and put it together and do something, like a bigger task. So this script isn't really doing anything, but it's showing what goes inside a typical script. The first line that you see, it's telling you that it's a bash script. There are other scripting languages. So bash is so this whole console that you're seeing, which is interpreting your commands and everything, which is handling your input, it's called the born again shell. That's just one of them. There is the original sh shell, and then there are many other shells that are there, and each has a slightly different syntax. But most Linux distributions, they ship with bash. That's the standard. So we'll consider that syntax. And all the lines which begin with this ## symbol, they are all comments, except for the first line, because it's telling, it has a special meaning, but all of these are comments. And then the echo command, you know what it does. So this angle bracket that you see, so it takes the output that was supposed to go on the screen and it writes it to a file. So if I did echo hello, it would have printed hello, but now it prints to this file. You can create variables in your script by writing them like, just pick a name and assign something to it. For example, like that. There are certain rules, you can read them. They are case sensitive, cannot have spaces or special characters. Now this here, the equal to sign, some people try to write, neat and clean readable code and they put spaces around it, but that's not, that's an error. Bash requires that you don't have any space around the equal sign. So that's a mistake I used to make a lot, but I just remember now that, if you want a variable, if you want to assign a value from the keyboard, you can use the read command. You can create a new, so to read a variable, reading and writing are slightly different. When you were writing something, you just use the name, but when you're reading its value, you use the $sign. So $x is used to read the variable. So y is equal to $x is assigning x to y, all of that. And you can use variables inside the echo command. So echo something 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 $y. As long as you're using double quotes, this works. Now sometimes you have to use the variable and write something right next to it, so there is no space or anything. So this is something, right? You have a variable a which has hello, and you're printing hello hi. But what if I did not want to put a space in between them? This doesn't work because it can't tell if it was a or is it a he, right? So this to resolve this kind of a scenario, you can put curly brackets around the name. So now it knows that a is something, hi is something else. So that's also there. If you're trying to do any math, like you have numbers and stuff, you can do basic addition, subtraction stuff by these double round brackets. It can do sine, cosine, those kinds of things, but just the basic stuff like that. This is useful. So sometimes you run a command, for example, the date command. It prints the what? Okay, yeah. So the date command prints the current date. If you want to store this, instead of printing it, if you want to store it into a variable, you say d equals and then dollar and then within brackets date. So anything that you put within these brackets gets executed and the result goes into d. So if you look at d now, that's the saved the contents of that command. So this is very useful and we'll be using it. Another thing is when you write a script and when you run it. So when I run my script, I can just run it by itself, right? No arguments, or I can type something A, B, C, D, or hello. So all these space separated segments, these are arguments. So this is argument 1, argument 2, argument 3, and so on, right? So within your script, they'll be accessible as $1, $2, $3, and so on. So we'll look at it later. And then you have the if-else command. So if condition, then, and then you can have some statements over here, and then else, and then some other statements. And this is one example. So if, and instead of the condition, I have a command. So what this does is, if this command was successful, if the directory was successfully created, it'll evaluate to true, and it'll say success, the folder was created. If it was unsuccessful, for example, the folder already exists, or you don't have permissions, it'll go to the else part and it'll print something else, and you can exit or something. So usually, so that's using the success or failure of a command in an if statement. The other usage is here, like with variables. So for numerical variables, you can use all these tests that I have. Equals, greater than, less than, greater than equal to, less than equal to, and so on, right? So you're comparing numbers. So just put them inside square brackets like that. So what is this $hash? I mentioned this up here. So $hash is the number of arguments that you pass. So if I run a command like script 1, 2, 3, so $hash will be 3. So sometimes, like if you are trying to make sure the user enters the right number of arguments, you can use a test on $hash. So we'll have something like this in our script. So there are a whole bunch of tests. There are tests for strings. You can have loops, a for loop. Again, a for loop is useful. A for loop is useful with files a lot. I mean, I use it with. So let's say I have a whole bunch of files here, right? If I want to do something on every file, I can write a loop like this: for f in star. Star means all the files, or I can make it more specific, like star.sh, right? And then do, and then echo f or something, like found f. So you can do here, right? So what it's doing is this generates all the file names, and f takes each file name one at a time. So usually you have a loop where the variable I takes number 0, 1, 2, things like that. Here f is taking file names one at a time from the list of files, and you can do stuff with that file. You don't have to. So a loop can be multiple statements. You can delete the file. You can do 10 different operations on it. You can rename all the files. So this for usage is very useful. I use it a lot with file names. And like just a hint or a warning or something, like if you're planning to delete or rename files, so instead of running the command, just print the command you are planning to run and just see what prints on the screen, so that if you notice any error in the command, you won't damage your files and things like that. Okay, so and then we have already talked about the find command. So now we go to our where is that? So the last thing, this is the script that I emailed you guys about. So what this script does is it Googles for a search term, and it counts, like when you go to Google, like if I search for UTA, for example, you see this with every search result, like about 53 million results, right? So our script is going to take all those terms and it will do a Google search, and it will just rank them on the popularity, you could say, right? So I'll just run an example. So it's already written. So let me just compare popularity of names, right? That's one usage. Let me compare myself with Donald Trump or okay. So I'm specifying 3 names to my script. Okay. So see these are the numbers. So for Donald Trump you have 90 million pages. Hillary, you have 61 million pages. For me, you have 36,000. And the most popular person is Donald Trump. So this script makes use of command line arguments. So $1, $2, $3, and it makes use of the sort command. It makes use of the sed command, because and it'll use this program called CURL. So this program lets you make a web request like this one. So if you look at this, the address bar, you'll see google.com/search/q equals UTA. So everything after that is actually useless. It's not important to the search, but for a basic Google search, that's the URL. The Q parameter is what you're searching for. So if you can send this request and get the response back, you'll get something like this page. And one way to do it is with the CURL command. Now you may not have it installed, so just run this, okay? Sudo apt, okay? Because it doesn't come installed by default, so we're gonna install it. I did that in the afternoon, but the command is sudo apt-get install and then curl. Okay. If you're trying to run it right now, if you're not, then that's fine. Now, if we look at the script, so the first thing it's doing is it's checking the number of arguments. So if the number of arguments is less than 1, so when you're running the script, you must have so if I just run it by itself, it's of no use, right? It doesn't. I didn't ask for anything, so if the number of arguments is less than 1, it will say you must give a few search terms and it exits. But if you run it with, for example, 3 arguments, it's just going to skip over this. So this is the most common use of the if statement and the $hash. Now I'm creating a few variables. This is the default Google search URL, and this is maybe not important, but yeah, this is the URL. And whatever term I'm looking for, I'm going to append it to the end of this. Okay. And I'm deleting 2 files because this script creates them. So if they're there from the previous time, I just want to get rid of them. Even if they're not there, this command fails, but the rest of the script continues. So it's no problem. Then this is different. This is a while loop. And again, here you can have a test like that, or you can have a command. This particular usage is, you can just remember this is for a particular case. It loops over all the overall arguments. So it repeats till the number of arguments becomes 0. And this is the so this shouldn't change, right? The number, if you gave 3 arguments, it should stay at 3. But the shift command, it gets rid of the first one. So you start with 3, this thing runs, it deletes the first one, you have 2, it runs, it deletes the first one, you have 1, it runs, then it deletes everything, and then the number of arguments becomes 0 and you get out. So this is the easiest way to access. So if you don't know the number, normally you could have just done $1, $2, $3. But if I don't know how many arguments I'll have, I must do something like this. Just remember that this is how you would handle a long list of arguments. So I'll pick the first argument, which will be $1 in this variable. And now the thing with the search is, if you have spaces in the search term, so UTA, you will see that the spaces get replaced by plus symbols, because URLs cannot have spaces. So we are going to use the set command to replace all the spaces with the plus, right? So S substitute spaces with the plus. So how do I apply this to this variable? I just print the variable, print it to the screen, but pipe it to the set command. And whatever, so you see remember this construct, dollar brackets, it means execute everything within the brackets and put the results here. So it's going to print this to the set command, and the set command is going to make some changes to it, and the whole result is going to go into the query clean variable. Now I'll append this to my search URL. So the final URL is the base URL. So I'm putting quotes here just because what if, like for example, I was searching for a name. I want to do a quoted search, like quotes, like treat the whole search term together. So since it's already within quotes, so I have to escape it and then the variable. So if we just did that and I printed it, and we exit it right there, So that's the substitution, and let's print the URL variable. So you see the base URL is right here equals, and then the quotes that I put in, and then the query clean variable. So you're doing some string manipulation here, that's all. Right, and then I'm calling the CORL program. Now the S is the silent option, because if you don't use S, it'll show a progress bar and everything. We don't want that, we just want the page, the result. So the S is that, and A is, I'm faking my identity as Google Chrome, because if you don't do this, it'll report that it's the CURL program, and many websites, they block it because they don't want scripts making requests to their servers, right? Because scripts can run hundreds of times a minute, and they'll just slow down their web server, so they just block all those programs. But you can pretend to be Google Chrome, or actually if you Mozilla, and there's supposed to be a longer string, a more accurate string with the version number and everything, but this works for now. And then I guess this specifies the URL -L URL, and the -O tells you that instead of dumping it to the screen, you save it to some file. So if we run this and we stop, it's going to make a request, and it's going to save it to this file. So if I go here and say, so this is the response from Google. Now you can't read it, right? It's all messy because they have a lot of JavaScript code, and they're trying to reduce the file size, so they remove all the spaces and everything. But what you're looking for is the word about. Yeah, this line here. Right, you see, about 36 something something. So it's somewhere on the page, but it's hard to see like this. But we don't have to, we can just use the set command. So the page was here, we're going to print the page and pipe it to the set command, right? And in the set command, we're doing something similar to what we did with the ifconfig, remember? So we are searching for anything in the beginning, and then about, and then some numbers, 0 to 9, with commas, because Google uses commas for the thousand separator. So any number, comma, more than one occurrence, collect all of that. So the brackets means collect them. And then this is also there, right? It's about 36,000 results. So we're trying to match all of that, and then anything at the end. Right? So this should match the whole line, and these brackets should grab just the number. And we're going to replace it by that number and print it. So the score variable should have just 36,000. If we and we exit, oh, right, so it ran through the whole page, and the set command, it extracted the number for us. So now I have the number in this variable score, and what I'm doing is I'm printing these numbers and the query in a list. So I'm going to make a table with numbers on the left and the search term on the right. So it'll print 36,000 in my name, 40,000 the other name, 50,000 the other name. So if we go and look, so this is what the program is doing. it's printing the score and the query and dumping it. So the two, so usually if we just had this one angle bracket, it will just take one result. So because this thing, it runs one line at a time, right? The while loop, first it deals with my name, then it deals with Donald Trump's name, then it deals with Hillary's name, right? So each time it's going to just delete the old file. But if you use two of them, it just adds it at the bottom. It's for appending. So it generates a file like this, and the last thing that we do, so that's the end of the loop. And the last thing that we do is we sort the file. So there is the sort command. Usually it sorts by alphabetical order, but numbers are not alphabetical order. So you have to do -n, and R means descending order. We could have done ascending order too, it's probably the same thing. And then, so I'm repeating the same command and I'm putting it through the head command. The head command can be used to view the first few lines of a file. So if I say head, it's or maybe some other file, it'll only print the first few lines. And if you want just the first line, you will say -n1. It'll print only the first line. You can print the first 2 lines and 3 lines and so on. So what I'm doing is, once I've sorted the file, I'm just printing the first line, which will be the highest scoring line, I guess. And then the cut command can be used to extract columns. Now, you could have directly used sed here and extracted the numbers or the name or whatever, but this is one way to do it. So yeah, so that's the end of the script, and you can do fun things with it. You can just you can compare UTA with UTD with UT Austin, and oops. So, huh? Oh, I don't know how it's possible. But it's true, so the numbers, they match up. So if I actually go to the Google page and say UT Austin, but I must quote it, okay, because so it's 835,000. Maybe it doesn't always exactly match up, but yeah, it shouldn't differ. I mean, the other cases I checked, it was matching perfectly. So maybe because it's so this is one example, right? I'm just querying Google and I'm looking for that particular thing. There are other uses that you can just think of, like the weather sites. You can query a weather site with your zip code, and you can extract the portion where it shows the temperature, the forecast or something, and you can do stuff with that. And this is not the best way to write, writing a shell script for this. There is this, I've never used it, but I know there is this program called, it's not a program, I think it's a whole language, or it's a Python tool or something, but I've never used it, and I don't know how much time it will take to learn and everything. But for simple things, this is good enough, right? A script like this. So you just make a query. Once you know how a website works, how the URLs work for that site, you can make a query and you can use CURL, and then you can parse the output using the sed command. So a simple way. So many websites will have, whether they call it the REST API or something, which is basically a URL like that. When you have to make a query, So let's see. Let's look at this. Yeah. See, so this is the API to request weather data by zip code. So the URL question mark zip equals. So ask the user for the zip code, put it here, a country code, and make a URL and use URL. So it's going to return something. Now this is called JSON, JavaScript object notation. There are libraries that will help you understand, and it converts it into a structure in a struct variable kind of. So you can directly say result.coordinate result.sys and like that. But we don't need to do that. We can just use the sed command. I'm looking for the clouds. I'll just say sed cloud something something. Give me the next thing within the codes. So you don't need to learn different tools and things. You can just work with the sed command. Not all the websites. So this works in a lot of places. It doesn't work in some places which require authentication, because some websites, they don't have open access. You must authenticate by a key. But that's also, I think it can be done. But most websites you can make requests and you can do stuff with it.